RFT is measured in people per second. This is the type of label that is on a velocity function. The question being asked is how many people. This is the type of label on a position function. The integral of velocity is the change in position. We want to find the change in position from time 0 to 300. Using your calculator, you next find the integral from 0 to 300 of the function r of t given. The answer is 270 people. Part A is worth 2 points. 1 point for setting up the integral, and 1 point for the answer. To find the number of people at time 300, we will need to consider 3 things. Starting with the number of people in line at time 0. Add to that the number of people who entered the line from time 0 to 300. Lastly, subtract out the number of people leaving the line from time 0 to 300. The number of people in line at time 0 is given. 20 people are in line at time 0. We already found the number of people entering the line from time 0 to 300 in Part A. A label of person per second indicates a velocity function. We will need to use this velocity function to figure out how many people are leaving from time 0 to 300. There isn't much to the velocity function for leaving. It's just the constant 0.7. So if we integrate that over the interval 0 to 300, we will find out how many people have left the line from time 0 to 300. The number of people in line at time 300 is 20 plus 270 people, which was the answer from Part A, minus 210 people, which is the answer to the integral from 0 to 300 of 0.7 dt. There were 80 people in line at time 300 seconds. Part B was worth 2 points. The first point was for considering the rate out, in other words, subtracting the integral from 0 to 300 of 0.7 dt. And the second point was for the answer, 80. In Part B, we figured out the number of people in line at time 300 is 80. R of t represents the rate that people are entering the line. For times greater than 300, the rate is 0 people per second. Since people are only exiting the line after time 300 seconds, we just need to figure out how long it will take for the 80 people that are in line at 300 seconds to exit. People exit the line at a constant rate of 0.7 person per second. Using this information, we can set up a ratio to figure out how long it will take for 80 people to exit. If it takes 1 second for 0.7 people to exit the line, then how many seconds is it going to take for 80 people to exit the line? We can cross-multiply and divide to solve for x. X equals 114.286 seconds. It took 300 seconds for there to be 80 people in line and another 114.286 seconds for those 80 people to exit. Therefore, the first time there are no people in line is at 414.286 seconds. Part C was worth just 1 point for the answer. We want to find the time when there is the least number of people in line. What it's asking us to do is find the absolute minimum. Potential absolute mins come from where the first derivative of the primary function equals 0 or the endpoints. So we need to start by building a primary function. The primary function always represents what it is you're trying to minimize. In this case, we are trying to minimize the number of people, so we need to write the equation of the number of people in the line. In part B, we wrote an equation that represented the number of people at time 300. If we just replace all of the 300s in the equation we created in part B, we will have an equation that represents the number of people at any time, which I am calling capital T. To find the derivative of P of t, you take the derivative of 20, which is 0, and then you take the derivative of the two integrals. To take the derivative of an integral, you use the second fundamental theorem of calculus by substituting the upper bound, multiplying by the derivative of the upper bound, minus substitute the lower bound, times the derivative of the lower bound. When we simplify, we get this. Then I'm going to go ahead and substitute the equation R of t. This isn't necessary, but it just makes it easier for me to explain. Now that we have the equation for the derivative of P of t, we need to figure out where it equals 0 for our potential mins and maxes. You just grab your calculator and enter the equation for P prime of t in your calculator and see where it crosses the x-axis between 0 and 300. The graph of P prime of t crosses at 33 and 166. The other potential absolute mins are the endpoints. T equals 0 and t equals 300. Now we need to decide which one of these is the absolute minimum. To determine which time is the absolute minimum, substitute each into the primary function that represented the number of people in line. You'll want to use the calculator to make these substitutions so that the calculator takes the integral for you. The smallest output was 3.803, so therefore the minimum number of people in line was 4 people when we round to the nearest person at time 33.013 seconds. Part D was worth 4 points. The first point was to set R of t minus 0.7 equal to 0. Here is my R of t minus 0.7, which is this. I set it equal to 0, giving me 1 point. The second point comes from identifying 33.013. I have that here. The third point is the answer. The answer included the number of people and the seconds. The fourth point came from the justification. Substituting in your endpoints and your potential local mins and maxes is the justification.